Well, hello YouTube. I'm back again with the phase of winding a toroid. I've already wound 3 toroids and put them in the radio. They were simple ones. I chose to videotape one and only one being done because it's tedious and boring and people aren't going to want to watch it. This is the biggest one in the radio. It's not very big, but it's actually going to be a transformer. It's going to have one winding, the primary, of 16 turns of red wire, and it's going to have a secondary of 4 windings of green wire. And it's fairly straightforward and not too bad to wind on camera, hopefully. I'm going to back this up a little, sorry. You can see this picture here. It says to follow this directly. The red wire is the gray wire on here and the green wire is the black wire. It shows how it's spaced out, and it tells you here the winding must be wound exactly as illustrated or the VFO will not function correctly. So this is pretty critical. The red wire is supposed to cover 85% of the toroid, and it leaves a small gap over here. And you will notice, well, as much as you can see it on camera, you can't because it's gray. It's really light text. Now you can. This one's coming out the top, this one's going out the bottom. Now technically that doesn't matter for your number of windings, but it's going to come into play when you go to solder it in, whether it's coming out the bottom or top. It also is going to change a little bit of the slant to the wire when you wind it around. It has a slight slant to it because you're going in one direction or the other. And you want the green one to overlap it and be in between. And if the slant's wrong, you get kind of this weird overlapping thing that you really don't want. So I'm going to follow this exactly. Try to anyway. I will confess I already screwed it up. I made another video that I deleted because I wound it the wrong way. I had it coming out the bottom when it was supposed to come out the top. And it only became a problem when I went to wind the green one and I realized the slant in the wire messed up the way they overlapped because of it, which was kind of really a pain in the neck. I tried to fix it and I couldn't fix it, and I finally said, you know what, I just need to redo it. So there's 16 windings. One pass through the core is one winding. This is all explained in the book. Not a wrap over the top of it, but through the middle of it is considered one winding. It really should be called one pass because it's really 16 passes through the core. But they call it a winding anyway. So we want to look at this picture and make sure my first winding going in this direction is coming out the top to ultimately be soldered down. So that's number 1, pass through 1. This is number 2, and I'm going to count them all the way around. Very boring, as I said, I know, but I want to at least have one winding of a toroid on camera. This is 3. I'm choosing to wind these myself instead of buying them from Elecraft because I want to be able to say that I completely built this kit myself. That is 3. I'm going to keep repeating the number so I don't lose track, and I'll double check myself at the end. That is 4. It's easy enough to recount them when you've only got like 16. You get into the higher number ones, and some of these have a lot of windings. You can't really count them once they're on there. There's just too many. That was 4. 1, 2, 3, 4. You get up, over like 20 of them, and forget it. 30, 40 windings, and some of them can possibly have that depending on the frequency. You lose track. You can't possibly count them, so you really got to pay attention to how many windings you have. 1, 2, 3, 4, 5, 6. 7. 8. 10, 11, 12, 'They're getting close together near the bottom, so I'm spacing them out a little. You can just use your fingernail or something and just move them around. 13, 14. You might be wondering why I'm using the short end. It's because I already stripped these, because this is the same piece of wire I screwed up and took back off. That was either 15 or 16. I started talking and lost track. So you get easy to do. Time to recount them. I'm going to do it under my magnifying glass, which is off camera, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. One more. Make 16. Okay. Now, we want it to look like the picture. It says it should cover 85% of the core, leaving a gap here between the two wires, a little bit of a gap, which I know you can't see, but a gap up here. See, I get out of focus if I move around too much. It's the trouble with autofocus, but then if I do manual focus, I'm going to be constantly stopping and trying to refocus, and that's just as much of a pain sometimes. So we'll skip the close-ups. You'll have to take my word for this that I'm sliding the wires on the core just a little bit to space them out properly. So I have close to what I see in this picture for spacing. Okay. There it is. I know you can't see the wires as well as I can, but they're the right. Okay, now the green wire is the secondary winding. It does only 4 turns. And we're going to go from inside out. So the first winding is winding over the top. Now I've already stripped it, so I'm going to make that stripped section come down right where that hole is going to be to solder it. First winding is a pain because it moves all over, but that's number 2. I should say the second winding is a pain. Once you have those 2 in place, the rest are easier. So the picture shows these interlaced in between the red one every other. So you got a green, you got a red, you got a green, you got a red, every other. And I'm trying to make sure that's where I'm going with this. Which is, and then I pulled on it too much and slid it. That's the thing. When you only have a couple windings and you pull on it hard, it just moves the whole stupid thing where you don't want it to go. And I have the added challenge that I stripped the wire before when I had it on before and I took it off again because I had it going in the wrong direction. So I'm trying to keep the stripped parts where I want them. Okay, 1, 2, 3, one more we got there. And we're going every other, we're in between. Goes red, green, red, green. Same gauge wire, they just give you red and green so to keep them straight. So you can, you know which is which, right? I'm going to say that looks good, except for the fact, let me just see something. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, yeah. It has... I should have counted it ahead of time. I know electrically the number of passes is the most important thing. And exactly which winding it goes in between probably makes no difference at all. But I'm going to be really anal about this and to match the picture exactly. 1, 2, 3, 4, 5. And I'm going to put it in between the same exact spot as the picture. Even though electrically, if it's over 1, it probably doesn't make one difference at all. But when I read in the manual, this must match exactly or the VFO will not function correctly. I'm going to have to pay close attention to that. 1, 2, 3, 4, 5, that is correct. What I mean by that is I have 5 red wire windings, and then in between number 5 and number 6 is a green, and then they're every other one for the next 4. That's what the book shows, that's what I'm doing. There we go. 1, 2, 3, 4. They are winding, and my right the same as the book. Okay. So there we have it. We have our primary on the left, secondary on the right. Next we put them back in the board. And I say back on the board because this is the second time I've had them in the board, which as I said, I screwed up and redid it. And by the way, I stripped the enamel off these with a little bit of emery cloth. There's different ways to do it. Some people like to melt it off. Some people use aspirin, believe it or not, melted aspirin with heat. Although that's more for Litz wire, which is a little bit different than this wire. But I find just emery cloth folded in half and you gently sand it off. You do have to be gentle because you can pull the wire right in half. You can break the wire if you're not careful. Okay, number 1 and number 2 are, and this is transformer number 5, by the way. I already know where it goes because I had it stuck in here before when I screwed it up the first time. So the primary is 1 and 2, the secondary is 3 and 4. The holes are numbered on the circuit board, and it is transformer number T5, which is for the VFO. So I'm just gently getting it down to where I want it. First of all, my one wire on the green side is a little loose. Why is that? There we go. Pull that tight. Now this direction, a screw actually goes through the middle of this, a nylon one. And it wants you to screw it down before you solder it. And the last time when I screwed it up, what I realized when I put this in the board the first time was the wires on the secondary winding were crisscrossed. and they were crisscrossed because I had gone in the wrong direction on the primary winding, and it put a slant in the wire, and they really didn't go in between them. They crossed over them instead of going in between them. And they all look in between now. Yeah, looks good. Let me, can I get a shot of this through this? Maybe. Yeah. Where is it on the camera? It's not going to focus. And it's too bright. I'm wasting my time trying to do that. I'm not going to be able to get a close-up easily on it. Take my word for it. It's in there properly. So once that's in, the wires are in the right holes. They're spaced out. The primary winding could be spaced a little better. I'm going to move them around. There's a little bit of a gap between 1 and 2. You don't have coverage over the entire core. It's 85%, as the book said. So I want to make sure I got that little bit of a gap. And it matches the picture, which it does. Then we secure it with the screw and the nylon washer. So there's a nylon screw and washer, which go down in between in the hole. And there's a nylon nut that goes on the back. And then it says make it snug but don't over tighten or you'll strip it, obviously, because it's nylon. So we're just gonna gently, need a different screwdriver. Where's that other one? Gosh, I am forever losing my tools on the bench. Snugging this down, blocking your view entirely, but that's being screwed down. Okay. How do we look? Could be over a little bit. This is the problem when I'm trying to film. I'm trying to show it to you, and I can't easily. It's more important that I get this correct than that I show it to you. Sorry. Trying to make sure the nylon screw is in the middle and not offset. And then I'm also looking at each individual wire and making sure they're still every other. I got red, green, like a Christmas tree. Like garland on a Christmas tree, red and green. Speaking of which, it's cooled off today here, finally. I think it was actually in the 40s, and I'm wearing a flannel shirt happily. I love flannel shirts. I've been wearing them since I was like 12 or younger. It was the thing to do in the 70s, right? Flannel shirts. You have to wear a t-shirt underneath and you'd roll up the sleeves to your elbows. I don't do that anymore. That was the style. I just wear the flannels with a t-shirt underneath buttoned up and the sleeves down. It's funny how that stuff stays with you. Completely out of style now. Well, I shouldn't say that completely, but for younger people, I'm sure. But back in the 70s, man, that was you were cool, man. If you had flannel with a t-shirt underneath and the flannel unbuttoned and your sleeves rolled up to your elbows. It's amazing how silly things are like that now looking back. It's like, okay, I thought I was cool back then, but you know what? I looked like every other kid in the school. But I was being an individual and I was being cool. Just like everybody else. Now I just dress for comfort. That looks good. We're going to flip the board and solder it. I might as well do it on camera. I actually have to, this board is fairly large, and I have to actually take it off my holder to flip it. The holder's made to spin, but it does not work with this big board. And then I also have to support it with the stapler. I'm not going to subject you to a lot of soldering on this video, but on these video series, I should say. But as long as I got the camera rolling and I'm at it, I'm going to solder these in on camera. Oh, the soldering iron's not on. It heats quick, don't worry. I think I probably mentioned it. I got a decent digitally controlled soldering iron from Radio Shack on closeout when they went out of business. Although I guess they're not 100% out of business. They are in most places. There's a few of them around still. We don't have any left. Okay. Well, let me check the tip here actually. Yeah. We're not quite there. I should be though. Just got to tin it a little. I gotta move my magnifying glass, yeah. I use a magnifying glass for through hole. My eyesight has gotten worse the older I've gotten. But I like to see the joint and make sure it's shiny and completely sealed with no cold solder joint. Now here's what I'm going to also do on camera. I always check these for continuity, and being a transformer, you're going to double check all of them. We are on, alright, I got my multimeter on. You'll hear the tone. I'm just touching them together. Here we go. That's one side. That's the other side. And now I'm going to go opposite. Uh-oh. Wait a minute. Is that possible? Why is it so intermittent? Let me look. 1 and 2 are the two closest to me. Yeah, I'd have to look at the somatic, but they should not be. Okay, there we go. You know, you get the flux in there. You know what I noticed? It must be my meter. I'm touching this all over the board. As soon as it hits a spot, it gives one beep, but it doesn't stay on. Or that's a ground plane, maybe. But if I do these two, it stays on. Stays on. Stays on. One beep does not stay on. One beep does not stay on. It must do that. If it's not if you don't have continuity. That's interesting. I think we're okay though. We have continuity on both sides correctly. I'll try not to bore anybody with any more toroids. I'm going to do the rest of these off on my own. Come back when a lot more are done. There's a whole bunch of them to do on this radio. I only have 3 done so far. All these band ones up here, they're going to have a lot more windings on them. They're going to be singles. There's a couple more transformers. There's a bunch over here. There's at least 10 more, if not more. But that's it for toroids. Thanks for watching. Okay, I'm back. I'm going to edit this into the end because I thought I was going crazy there with my VFO transformer. I wanted to show you why I was getting these strange beeps, because I figured it out. Looking at the schematic, which I will try to get clearly on camera, I hope. Better or worse? You try to get more light and I get glare. Doesn't always work. Let's try this. Boy, it's hard not to get glare on that white background. What a pain in the neck. Sorry for this. This is the VFO section up here. This is Transformer 5 right here. Which we will try. It just doesn't want to focus where I want it to be. Transformer 5. 1 and 2 is the primary, 3 and 4 is the secondary. 1 and 2 goes to ground. And then it goes off through a coil to ground. And then 3 and 4 go through a capacitor to an op amp type thing. And then down below it goes through an electrolytic to ground. So think about that. I have a ground through an electrolytic on one side, and then on the other side I have it to ground plane, which explains the strange pattern I'm getting on the continuity of this thing. So if I flip her over, we have, there's my beep. Okay. I'm going to go to 1 and 2. This is pin 1 and 2 to a ground. I'm going to go to a ground spot, which is any of these metal things. It's on the ground plane, okay? Now if I take it to the secondary side, it beeps and stops because there's a capacitor to ground. in between it. So that does make sense. The most important thing is from side to side, from pin 1 to pin 2, I have continuity. From pin 3 to pin 4, I have continuity. And then across them, I just get that one little beep. That's what was throwing me off. Why is this thing just beeping once and stopping? I think it's because there's a capacitor to ground on the one side of it. So you get that kind of little charge and release situation going on there. Even though there's no electricity through this yet, there is a little bit of a current going through there from the multimeter. I believe. I think I'm right. Hopefully. Thanks for watching.